Number 9 from the Fall 2012 Exam 4 is center mass problem. Like most problems, we have uniform thickness and density, and in this one we want to determine just the x-coordinate. All units are in centimeters, so we have given a coordinate system. Okay, so we'll have to use that as our reference. Okay, we have to decide how to divide this complex object into simpler objects and then combine them. Okay, several ways of doing that. The way I'm going to choose to do it is use this red rectangle that is 18 by 12. Okay, I'm going to locate the center mass of that. We're only concerned about the x direction. Okay, so we'll just do that in this particular problem, and that's 9 away from the origin, and its area is 18 times 12. And 18 times 12 is 216 square centimeters. Alright, we'll go ahead and work with the other positive area. Is this small rectangle right here. Center mass located right there in the center. So we're going to use this distance of 18 plus half of 4, or 18, and it looks like about 20. Okay, and its area, proportional to the mass, is 4 times 2, which is 8. Okay. The last part is this triangle portion. So I'll draw it in green here. It's going to be a cutout, or a void, or a hole, whatever you want to call it. On this problem, we did give you the equation for the location of the center mass, and we will do that for any shapes other than the very obvious circles and rectangles. So it was given. I scroll back up, on the cover page right here. Okay, for a right triangle, we've got a base and a height, and the centroid is located 1/3 of the way from the right angle edge in both directions. So that's going to be our location. We expect you to know the equation for the area of a triangle. So somewhere right in here will be its centroid. Its x distance is 1/3 of this distance, 1/3 of 8, or 2.667. Okay, its area is 1/2 its base of 8 times its height of 6. 6 times 8 is 48, so that looks like 24. Okay. So given all those numbers, we can use the equation for the center of mass in the x direction, sum of all the individual parts times their center mass times each individual mass times the sum of all the masses. Again, this triangular value is going to be negative. Okay, so that's how to write it here. I'm going to write it down here. So x bar is going to be, and we'll use color coding since we have it here. The blue was, I guess I'll do that one. I'll do the red one first since I started with that. My description. So its x bar is going to be 9 and its area is going to be 216. Remember, area and mass are proportional because of uniform thickness and density. Okay, we'll add in the blue part. Centroid of 20 in the x and an area of 8. Okay, we have to subtract off the triangular area. It's a cutout, and its centroid was 2.667 and its area was 24. Okay, and we'll add up all these. The area plus that area minus that area. Okay, almost messed up. This area was just 8. Okay. So, into the calculator it goes. So I can see it. 9 times 216 plus 20 times 8 minus 2.6667 is good enough, times 24. Okay, so that top number's 2040. And the bottom number is 221.33. Yes, that gives me a centroid of 9.22. Oh, it's early in the morning and I see a mistake here. I wrote it out right, but I didn't punch it in the calculator right. This number here on the bottom, I think I punched in the 2.667. It should have been 24. 216 plus 8 minus 24 is simply 200. And this number comes out to be 10.2. We're working consistently in units of centimeters. Don't forget the units. Okay, if we were just looking at this shape overall, it's 22 wide, 18 plus 4, so we would expect a number less than 11 because we've got this cut out and this cut out. We would probably expect a number greater than 9 because it would be somewhere to the left, or excuse me, to the right of the centroid of this red rectangle, because we've added a bit of mass at a far distance. So that would shift the centroid to the right a bit.